lesson, you have learned about parameters and areas of plane figures, like rectangles, squares, triangles, trapezoids, circles, sectors of circles, and etc. These are called plane figures because each of them lies wholly in a plane. However, most of the objects that we come across in daily life do not wholly lie in a plane. Some of these objects are bricks, balls, ice cream cones, drums, and others. These are called solid objects or three-dimensional objects. The figures representing these solids are called three-dimensional or solid figures. Some common solid figures are cubes, cylinders, cones, pyramids, and craters. Today's lesson deals about the surface area and volumes of all these solids. But before we begin, I prepared a video that will give you an idea of what our discussions will cover.
Work it, make it, do it, makes us harder, better, faster, stronger. Work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it never over, work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it never over, work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it never over, work it never over, do it, work it never over, harder, work it never over, better, work it never over, work it never over, do it, work it never over, harder, work it never over, harder, better, faster, stronger. Work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it harder, make it better, do it faster, makes us stronger, more than ever, hour after hour. Work it harder, make it better, do it faster, makes us stronger.
So that's it. We can see lots of solid figures all around the world. And even the world is a solid figure. So fasten your seatbelts because we now begin. First, we will begin with defining and unlocking the terms lateral area, total surface area, and volume. The lateral area of a solid figure is combined area of its lateral faces. For example, given a bedroom in the shape of a rectangular prison, the lateral area is the area of the four walls. Another example is given a cylindrical soup can, the lateral area is the area of the can's label. The total surface area of a solid figure is the combined area of its lateral faces and its faces. For example, given a bedroom in the shape of rectangular prison, the total surface area is the area of the four walls plus the area of the ceiling and the floor. Another example is given a cylindrical soup can. The total surface area is the area of the can's label plus the combined area of the top and bottom of the can. Next is the volume of a solid, which is the number of cubic units which fit inside the solid. For example, given a cylindrical soup can, the volume is the amount of soup which can be contained in the can. That's what this term means. We are now ready to discuss the different solid figures. We now begin with simplest solid figures, which is the cube.
A box is an example model of a cube, with each face of the box as a perfect square. This means that every edge of the cube is the same length, and we call the length S. The area of the one of the faces is the area of the square, which is S times S or S squared. The surface area of a cube is the combined area of all its faces. So a cube which has 6 faces, front and back, top and bottom, and left and right, has a surface area equal to 6S squared. S squared is the area of one of each faces, and there are 6 faces. And don't forget that the cube is measured in inches, centimeters, or feet. The surface area will be measured in square inches, square centimeters, square feet, also for consistency in the units of measures. Remember that we can find the volume of the prism using the formula volume is equal to length times width times height. Here, our prism is a cube. Since the length, width, and height of the cube are all equal, we can find the volume of cube by multiplying the side times side times side. So we can find the volume of the cube using the formula volume equal to S cubed. And the cube shown here, notice that we have side length of 5 inches. So plugging into the formula, we have volume equal 5 inches cubed. Where 5 inches times 5 inches times 5 inches, which is 125 cubic inches. So the volume of the cube shown here is 125 cubic inches. So that's the surface area and volume of a cube, wherein the formula of the surface area of a cube is 6S squared, where S is the side of the cube, and for the volume of a cube is S cubed. Now let's move on the rectangular prism.
That's the surface area and volume of a cube, wherein the formula for the surface area of a cube is 6 times S squared, where S is the side of the cube. And for the volume of a cube is S cubed, where S is the side of the cube. Now let's move on to rectangular prism. The values assigned to me are the lateral surface area, the total surface area, and the volume of a rectangular prism. The lateral area of a figure is the area of the non-base faces only. When a prism has its bases facing up and down, the lateral area is the area of the vertical faces. 2, 2. For the rectangular prism, any pair of the opposite faces can be bases. To get the lateral area, we need to get the sum of all lateral faces. The lateral area of a right prism can be calculated by multiplying the perimeter of the base by the height of the prism. This is summarized by the formula lateral area is equal to P times H. Since we are working with a rectangular prism, we have a rectangle as a base. In fact, we have 2 bases. Now, we need to find the perimeter of one of the bases. The perimeter of one of the bases is also the perimeter of the other base. Now, to find the perimeter of a rectangle, we use the formula 2L plus 2V. For example, George is is in the box, shaped as some right prism. We want to determine the surface area and the lateral area of the prism to see if he has enough wrapping paper to cover the entire box or only the vertical faces of the box. That's how we will solve the problem. First, we already know the formula for finding the lateral surface area of a rectangular prism, which is LA is equal to P times H, where P is the perimeter of a rectangular prism and H is the height of the prism. So we go for finding the surface area of a rectangular prism. To find the surface area of a rectangular prism, we have to get the sum of all the area of the faces, including the two bases. So, for us to find the surface area, first we need to find the area of the bases. Now, remember that since we are working with a rectangular prism, we know that the bases are congruent, so the area of one of the bases is also the area of the other base. Since this is a rectangular prism, the base of this solid figure is rectangle. So for the area of the base, which is a rectangle, and the formula will be A is equal to length times width. Since every opposite faces are congruent, we derive the formula of 2 times the quantity length times width, length times width, plus width times height, plus length times height. So the formula of the total surface area of a rectangular prism is equal to 2 times the quantity length times width, plus width times height, plus length times height. Going back to the problem, we will now answer the following questions. What is the lateral surface area and what is the total surface area? First, we find the lateral surface area, which is equal to LA is equal to P times H, where P is the perimeter of a rectangle and P is equal to 2L plus 2 width. So we have 2L plus 2 width and H. By substituting the given measurement for L is equal to 1.5, width is equal to 0.25, and H is equal to 1.0, we now have 2 times 1.5 plus 2 times 0.25, the quantity 1.0. So by simplifying, we have 0.5 plus 3, the quantity 1.0 is equal to 3.5 square units. And for the total surface area, we have SA is equal to 2 times the quantity length times width times height, plus length times height. By substituting the given measurement, we have 2 times the quantity 1.5 times 0.25 plus 0.25 plus 1.0 plus 1.5 times 1.0. By simplifying, we have 2 times 0.375 plus 0.25 plus 1.5 is equal to 4.25 square units.
Apa yang nangyayari ko? Magbilang ka ko nga pala 5, Ben. Pag-git ng bilang.
For a two-dimensional rectangle, we have a formula of the product of length and width. But how do we find the formula of rectangular prism considering it is a three-dimensional figure? A rectangular prism has length, width, and a height, while for rectangle, we have length and width. For example, this figure has a length of 8 units, height of 5 units, and the width of 5 units. Since the base has dimension of 8 units by 5 units, then we fill the prism with 40 cubes with a measurement of 1 unit per cube.
Since our height is 5 units, then we fill the prism with 40 cubes 5 times, where 8 is the length times 5, which is the width, is equal to 40. Then 5 times again for the height, so we have 200 units. So then we derive with the formula of V, or volume of a rectangular prism, is equal to length times width times height. That's for the rectangular prism. We go now to the figure which looks like a can. And we call this figure as cylinder. How do we find the surface area and volume of a cylinder? That's the next thing that we will do.
A cylinder is a three-dimensional geometric solid bounded by two equal parallel circles or its bases, and a curved surface formed by moving a straight line so that its ends lie on the circle. We are here to know how the surface area and the volume of this solid figure were derived. So let's start with the surface area of a cylinder. As we know, the formula in getting the surface area of the cylinder is SA is equal to 2 pi r square plus 2 pi r h. Where did 2 pi r square came from? So 2 pi r square is the sum of the area of two bases, which are two circles. As we know that the formula in getting the area of a circle is A is equal to pi r square. Then multiply it by 2, for it has two bases. So we get 2 pi r square. When you unwrap a cylinder, the lateral face becomes a rectangle. The area of the rectangle is the product of its two sides. One side is the height of the can and the other side is the perimeter of the circle, also known as the circumference of a circle. So it is where 2 pi rh came from. Add those two parts together and you have the formula for the surface area of the cylinder. Given a radius of 6 cm and a height of 10 cm, we are able to get the surface area of the cylinder. Substituting it to the formula, we will come up with this. So 2 pi 6 cm squared plus 2 pi multiplied to 6 cm multiplied to 10 cm. By simplifying, we will get 2 pi 36 square centimeter plus 2 pi multiplied to 60 centimeter square centimeter. Simplifying again, we will get 72 pi square centimeter plus 120 pi square centimeter. By addition, we will get 192 pi square centimeters, wherein pi is equal to 3.40. Therefore, the total surface area of the cylinder given a radius of 6 cm and height of 10 cm is equal to 602.88 square centimeters or 602.9 square centimeters. Using the same example, R is equal to 6 centimeters and height is equal to 10 centimeters, and substituting it to the formula, we will come up with pi, the quantity 6 centimeters squared multiplied with 10 centimeters. So we will get pi, the square root of 6, which is equal to 36 square centimeter multiplied to 10 centimeters. By simplifying again, we will get 360 cubic centimeters pi, wherein pi is equal to 3.40. Therefore, the volume of the given cylinder is 1,130.4 cubic centimeters. Recalling the solid figures that we had discussed, we had cube, rectangular prism, and the cylinder. Do you guys know the title of this song? Yes, it's Pyramid by Trace. And this is the next figure that we will discuss, which is the pyramid. In finding the surface area of a pyramid, we limit only our discussion on the study of regular right pyramids. A right pyramid is a pyramid in which the apex is directly above the center of the base. First, let us define and illustrate a few important terms. The height of a right pyramid is the distance from the apex of the pyramid to the center of its base. The height is denoted as letter H. The slant height of a regular right pyramid is the distance from the apex to the midpoint of the side of the base. For example is the height of one of the lateral triangular faces. The slant height is denoted as letter L. Remember that in a regular right pyramid, all slant heights are congruent since all of their lateral faces are congruent. Consider this right pyramid with a height given 12 cm and a base given as 10 cm by 10 cm. We want to find its lateral area and total surface area. Notice that the slant height is not given. You will first draw a right triangle within the right pyramid and find the slant height, which is denoted as letter F. Of the triangle intersects the center of the base, we know that the horizontal leg of the right triangle is 5 cm, which denoted as letter A, which is half of the 10 cm, which is the side of the square base. We then use the Pythagorean theorem to find the slant height. So, h squared is equal to L squared plus A squared, where we're going to substitute the given values. So h is equal to 12 centimeter squared is equal to L squared plus 5 centimeter squared. By simplifying, 144 square centimeter is equal to L squared plus 25 square centimeter. By subtraction property, we will have 144 minus 25 square centimeter is equal to L squared. And for simplifying, L squared is equal to 169 square centimeter. And finding the value of letter L, L is equal to the square root of 169 square centimeter is equal to 13 centimeter. So the slant height is equal to 13 centimeter. The base of this pyramid is a square, and the lateral faces are triangles. Notice that the height of each triangular lateral face is 13 centimeter, not 12 centimeter. Remember that the slant height is the altitude of the lateral face, which is triangle. The lateral area of the square pyramid is the sum of the areas of the four congruent triangles. In finding the area of a triangle, the formula is 1/2 base times height. So, lateral area is equal to 1/2 times the base, which is 10 centimeter times the height, which is 13 centimeter, plus the second base, which is 1/2 of 10 centimeter times 13 centimeter, plus the third triangle, 1/2 times 10 centimeter times 13 centimeter, and the last triangle is 1/2 times 10 centimeter times 13 centimeter. By simplifying, we will get 65 square centimeter plus 65 square centimeter plus 65 square centimeter plus 65 square centimeter. By adding, we will get a total of 260 square centimeter. Therefore, the lateral area of the right pyramid is 260 square centimeter. Actually, there is a shortcut for finding the lateral area of a regular right pyramid. In the equation for the lateral area, we will factor out 1/2 times 13 centimeter. So, this will be 1/2, factor out 1/2 and 13 times the remaining 10 centimeter plus 10 centimeter plus 10 centimeter plus 10 centimeter. In this formula, this 410 centimeter represents the perimeter of the base, and 13 represents the slant height of the right pyramid. So by simplifying, we will get the same answer as 260 square centimeter. That is how to find the lateral area of a pyramid by just adding the four areas of the lateral faces, which are triangles. So the general formula for the lateral area of a right pyramid is L is equal to 1/2 times the slant height times the perimeter of the base. The total surface area of the pyramid is the lateral area plus the area of the base. We had already solved the lateral area, which is square centimeter. So, the total surface area, which is TA equal to lateral area plus the area of the base, which is B. The lateral area is 260 square centimeter and the base is 10 centimeters squared, which is the area. By simplifying, 260 square centimeter plus 100 square centimeter. By adding, we will get a total surface area equal to 360 square centimeters. Therefore, the total surface area of the pyramid is 360 square centimeters. So, the general formula for the total surface area of a regular right pyramid is TA equal to LA plus B, where LA represents the lateral area of the pyramid and B represents the area of the base. Right pyramid, a cube and the pyramid having the same height and base. Suppose that we want to compare the volume of these following solids. If we decided to fill the pyramid with rice grains and then pour it into the prism, what will you observe? We then continue this process until the cube is completely full of rice grains. How many pyramid fulls of rice grains do you think would fit into the cube? It turns out that we would need to fill the pyramid 3 times. In other words, if a pyramid and a cube both have the same base and height, the volume of the pyramid is 1/3 the volume of the cube. So the formula in getting the volume V of a pyramid is 1/3 times base times height, where B represents the area of the base and H represents the height of the pyramid. So the formula in getting the volume B of a pyramid is 1/3 B times H, where B represents the area of the base and H represents the height of the pyramid. This formula applies to any pyramid, even if the base is not regular and if the pyramid is not a right pyramid. For example, we need to find the volume of a regular right pyramid, where the given slant height is equal to 10 inches and the base whose dimensions is 12 inches by 12 inches. We first need to find the height of the pyramid. We draw an altitude to the base of the prism and form a right triangle. We can then use the Pythagorean theorem to find the height. So, H so 10 inches squared is equal to H squared plus 6 inches squared, where 6 inches is the measure of half of the base of the square, which is 12 inches. So by simplifying, this will be 100 square inches is equal to h squared plus 36 square inches. By subtraction property, this will be 100 minus 36 is equal to 64 square inches. Then h squared 36 inches minus 36 square inches is equal to 0. So this will be 0. Then by simplifying, h is equal to the square root of 64 square inches, which is equal to 8 inches. The base of the pyramid is a square, which area 12 inches squared, which is now equal to 144 square inches. The height of the pyramid is 8 inches. Therefore, the volume V is now equal to 1/3 times the base, which is 144 square inches, times the height, which is equal to 8 inches. And then by simplifying, we will get a volume equal to 384 cubic inches. Therefore, the volume of the given pyramid is equal to 384 cubic inches. We are already finished with the cube, rectangular prism, cylinder, and pyramid. The last solid figure that we will discuss is a cone. So, buckle up because we will soon be done with our discussion. The essence of this representation is why we don't need anymore to memorize the cone volume formula. As a review, recall that the area of a circle is equal to pi r squared. And a circle is a bottom of a cylinder. If we find the area of a bottom of a cylinder, we will multiply with the height, and we are already getting the volume of a cylinder. This is why we don't need also to memorize the full formula in finding the volume of a cylinder. Just remembering the formula for area of a circle. This would take same process for a cone. The technique is the volume of a cone is another formula which we will not memorize. Look for this formula. It is exactly the same as the formula of a cylinder. It means that the formula of a cone must be 1/3 the volume of a cylinder. Well, it will all be the true if the radius and the height of a cone is same as the cylinder. Archimedes first showed that the volume of a cone is exactly the 1/3 of the volume of a cylinder with the same radius and the same height.
I have here a cylinder and a cone made out of aluminum. Take note that the cylinder is not perfect and the cone roughly have the same radius and height as the cylinder. And if Archimedes is right, we should fill the cone 3 times to fully fill the empty cylinder. Let us see if the cylinder is fully filled with 3 cones of rice grains.
I am very confident and convinced when Archimedes said that a cone, if it has a radius and height as the cylinder, will have 1/3 the volume of cylinder. If we can remember a couple of simple facts about a cone and a cylinder, then we will only have to memorize is the formula of a circle, which is pi r squared. And if you know the area of a circle formula, multiplying it with the height of a cylinder, you get the formula of getting the volume of cylinder because it has a circle bottom. And if you know already the volume of cylinder formula, divide it by 3 to get the volume of a cone that has the same radius and the same height as the cylinder. As for the conclusion, as long as you know basic formulas such as finding the area of a rectangle, square, or triangle, it is not impossible for you to get the surface areas and volumes of the different solid figures.